hypothesis testing. Okay. So module number 14 deals with intro to hypothesis testing. Hypothesis tests are designed to test the validity of a stated hypothesized value for a specific parameter. So the parameter that we're looking for, okay, the three parameters that we focus on are what? Mean, proportion, and what? Standard deviation. Those are the three parameters that we focus on, right? This leads us to questions of the form like, is the population proportion more than 90% of proportion? Okay. I think the population mean is 240 millimeters, right? Am I right? Mean, and as you could see, right? Okay, we're going to be looking at hypothesis testing, right? And what is a hypothesis testing? Okay, we're going to be dealing with different type, again, proportion, mean, and standard deviation. Okay, we're going to be looking at different terminologies and notation. But before we actually do this right here, suppose, Timothy, what sports do you play?
Football.
Football. Atir, do you play football too?
No, I'm in track and field.
Excuse me?
I'm in track and field.
Oh, you're in track and field. What event or what is it?
The throwing events, so like shot, hammer, disc.
Oh, shot put, hammer. Okay, got it. Oh, awesome. Well, let me just say this. So let me give you an analogy of what hypothesis testing is all about. Suppose that Timothy, right, plays basketball, okay, and I play with them, right? And then I say, oh, okay, and then Professor E, you are a terrible basketball player. You can't shoot a free throw, Timothy says, right? And then I seen you play basketball. You're like, you know, and then I said, you know, I've been practicing. I tell Timothy, I'm like telling him, I've been practicing a lot. And then he's like, no, your free throw is really bad. You know, it's like your free throw is probably like 40%, right? I'm like, I've been practicing. I've been doing much better than 40%. Okay, so basically, Timothy is claiming that, oh, you know, I know you, right? You're a horrible basketball player, right? You're free throw shooting, right? So Timothy claims that, you know, Tim, let me write Tim, says that, oh, my free throw percentage, we'll call that proportion, is equal to 40%. Okay. What I claim right now, I am trying to claim that, oh, you know, I've been practicing off court, whatever it is, off the time, right? And I've been practicing and it has much improved. And I say, oh, it's going to be much greater than 40%. And that's just me. Okay, usually this is considered to be your null hypothesis, and this is your alternate hypothesis. Okay, so first again, I'm claiming, right, that's me. I'm claiming that I've been practicing a lot, right? And then Tim says, BS, right? Prove it, right? And then what do I need to do, right? Atir, what do I need to prove to him? How do I prove to him that you know, my free throw has gotten much better than 40%? Oh, he's not responding. Okay, Adrian, what do I need to do to prove to him that it's gotten much better than?
Shoot 10 free throws in front of him, and then...
Yeah, or I go out and I say, okay, I'm gonna shoot 4 free throws, right? And then I go out and make 3 out of 4. What's 3 out of 4? Tim, what's 3 out of 4?
75%.
75%, right? And then I say, oh, does that prove to you that, you know, look here, I'm shooting 75% free throw right now, right? Does that prove to you that I shoot better than 40%? Yes or no?
Yes.
Yes, you think so? You're like, Adrian, do you think so?
Not really. It's like I don't think you have enough data. Like you don't have enough.
Right, very good. Like, no, you only shot 4 free throw. You lucky shot, right? Lucky shot, right? Prove it, right? It doesn't prove it. Not enough, right? They're like, oh, shoot 100 free throws, right? And let's see if you make actually, more than 40, right? Then I could see that, oh, okay, I have enough data that I could actually definitively say that, oh, I have actually, Professor E has actually improved on his free throw. Okay, that's the basic concept of what hypothesis is all about. Okay, hypothesis testing. So what we're trying to do is whatever claim we're trying to actually prove. Okay, whatever I claim. And the other claim, which is what we call the null hypothesis, is always what we consider to be equal to. Okay, and then we normally use null hypothesis in a courtroom, right? Okay, a defendant comes in, right, as a suspect of some type of crime, right? A defendant comes in. That defendant is always, right, okay, innocent until what?
Proven guilty.
Until proven guilty. So therefore, your null hypothesis is similar to that of saying innocence. It's always innocence until proven otherwise. Okay, what do you mean otherwise? So in mathematical inequality, there's only 3 types of mathematical inequalities. Okay, or there's actually 5 types of mathematical inequality, right? Okay, or 4 types and inequalities here. So we have less than or equal to, but they're the whole thing. We are just gonna group that together. Greater than, or greater than and greater than or equal to, and there's a not equal to. Okay. So when we actually say that, oh, mine, right? For me, when I asked, about the free throw shooting, I said, oh, it has improved. One of the keyword that I'm using in equality, improve. Okay, increase, right? Greater than, right? These are all keywords that indicates that I'm using greater than, or equal to. Okay. Okay. So far so good. Any question? Okay. It doesn't matter which of these 2 you use, greater than or greater than equal to. They're both okay, right? Okay. For this one, right? Okay. Decrease, right? Less than, right? And so forth, right? Okay. Gone down. Okay, these are all like keywords that you will use to indicate your inequality to be less than or equal to. Okay, this one right here, when we have, right, not equal to, has changed, right? Is it different? Right? And these are keywords that we use to indicate that it is not equal to. Okay, so far so good. Okay. So the only thing that changes here is alternate hypothesis, your claim. Okay, I'm claiming that it has improved. I'm claiming that, oh no, my score has, or my I haven't been practicing, maybe it has gone down, right? My percentage has gone down, right? And so forth, right? Has changed, whatever it is, right? So hypothesis test. Okay, so far so good. Kind of get the idea, right? What we're trying to do is we're trying to, right, you as a prosecutor, as a statistician, prove your claim, whatever your claim is. Has it improved? Has it, decreased, or has it changed? We want to, right, with data values and with using statistical analysis, we want to actually prove scientifically using mathematics that it has actually gone up, come down, or not equal to, and so forth. Okay, so there's two different type of hypothesis. There is null hypothesis and alternate hypothesis, right? Okay, null hypothesis is the value of no change. As you could see, no change. Okay, null means no change, always equal to. Okay, always equal to. It is the value of a parameter that's set before we run the test. Okay, set before. Again, same idea as being a defendant being innocent until proven guilty. We already will, right, indicate that the defendant is always innocent. So null hypothesis has always no change, always equal to, right? Usually it is the value obtained from previous report and or study. Okay, null hypothesis always have the same equal sign, always the equal sign. Okay, alternate hypothesis, the relationship between the parameter and given values we are testing. Okay, it is more or less, less, more, or just different, right? Less, more, or just different. So we have less, decrease, increase, and not equal to, right? Alternate hypothesis has one of the following symbol: less than, greater than, not equal to, or it could be less than or equal to, greater than or equal to. That's okay too. Okay, so far so good. Any question? Okay, all right. So always identify parameter. Are we dealing with proportion? Are we dealing with mean? Are we dealing with standard deviation? Okay, so once we figure out the parameter and the characteristic that we're looking for, then we actually follow direction. Proportion, we have three hypotheses here: less than, greater than, and not equal to. Always your null hypothesis, as you can see that this is always equal to, proportion-wise, right? So for proportion, you're using p-value. For mean, you're using mu. And for standard deviation, and they're exactly the same. Don't memorize this, right? You just have to memorize just the null hypothesis. Null hypothesis always equal to, and the parameter will always change depending on what type of, right, information you're given. If you're given a proportion, then it's going to be dealing with p, right, and so forth. Okay. Look at individual rows. What is the common throughout the whole row? Y. Look at the individual column. What is the common throughout the whole column, and why, and justify. Okay, so so when we have less than, okay, if it's less than, right, if your null hypothesis, alternate hypothesis less than is a left tail test. If it's greater than, or greater than or equal to, right, is a right tail test, and we have not equal to is considered to be a two tail test. Okay, and we'll talk about this a little bit later. It's not all that important if we're not doing this by hand. If we're utilizing StatCrunch to do this, right, you don't necessarily need to emphasize too much about what it is. Is it going to be a left, right, or two tail? Okay. All right, so what is a hypothesis test really? I kind of give you the information. This is the overview of what hypothesis test is all about. Okay, let me give you the technical form. The idea behind hypothesis test is to put the null hypothesis test on trial. Okay, it is very much resembles an actual law trial in many respects. Okay, we want to see if the evidence we get from a sample rejects the null hypothesis or not. Okay, once we have set up the two hypotheses for the test, we proceed in the following way. Assume that the null hypothesis is true, like assuming innocence until proven guilty, right? Always true. Okay, collect the sample data and calculate the corresponding statistic. This is called the, corresponding statistic. This is your test stat. Okay, and we find the conditional probability of getting my sample result, or one more extreme, given that the null hypothesis is true, the probability directly addresses the question of variability. Okay, is the variation something we could expect if the null hypothesis is true, or is it appears as though something unusual has occurred? Okay, so unusual has occurred, and we'll talk about this. If the condition probability is low, i.e. the variation from the null hypothesis appears to be significant, we reject or not reject null hypothesis and support or not support the alternate hypothesis. Okay, what do you mean? Okay, let me give you another example here. Suppose, okay, I think, let's see, okay, so here, I think, who is it? Who was there last night? Alexandra actually heard this before, okay? Okay, so Alexandra Martin, right? So we have a crime scene. Okay, so far so good. Okay, and we caught a suspect. Okay, we caught a suspect. Okay, suppose let's actually get rid of this right here. Let's get rid of this right here. So we caught a suspect. This suspect has no relationship, right? There was a crime scene and there was a person that was murdered at their home, right? And we caught a suspect, right? But this suspect has no relationship whatsoever, okay? No ties whatsoever. He's not a friend, he's not a relative. He has never lived around, you know, this person right here, the murder victim, right? Okay. So what's the probability, Michael, if I ask you, what's the probability that you will find his, right, the suspect's DNA in the crime scene?
Like 0% or like
0. Very good.
Yeah.
Almost impossible. If he has no ties to the, right, the murder victim, right, there is gonna be 0% chance that his DNA will be in that crime scene. Okay, and then the investigator goes in, and then they actually discover there was a little hair. Okay, and it turns out that this hair belongs to the suspect. How significant is that finding? How significant is that finding?
like really significant because
Oh, very significant, right? If he has no ties to him, right? He never lived around his neighborhood, right? He's all far away, right? To find his DNA in that crime scene is 0 to none, basically, right? And if we find it, it was nearly impossible event that had occurred, right? And it has occurred, right? Which means that this hair is very significant evidence that he actually committed the what? Crime. Get the idea? Okay, now let me tell you, what if this suspect, okay, now let me erase this. Suppose that, so therefore, the probability of finding that hair is 0 to none, but we found it. And that's considered, in statistics, we consider that to be a very, very small probability of finding an evidence that ties to him, right? That's the probability. Very, very small probability. That's what we call the p-value. And that p-value, smaller the p-value, bigger the significance. right? Significance. Why? The probability is 0 to none, and we found it, and that's highly improbable that his hair or his DNA is in that scene, right? So the p-value is very, very small, and we found it, and we say, oh, then we know that is highly significant, then that is the suspect, and he's gonna be, right, put to trial, and he probably find guilty, right, of his crime. But now suppose, let's see here, okay, let's make this different. Okay, now let's say that this person that we caught, wife, and this person is the, okay, so now, Adrian, let me ask you. The person, the suspect of killing that person, right? The murder victim is actually considered to be the wife, right? The suspect caught. She's not put to, she's put on the trial, right? But she's not found to be guilty yet, right? Okay. Now, when they're going through the trial, they found the evidence that her hair is in that crime scene.
Or her hair would be like in that house, wouldn't it?
Yeah, her DNA, right, in their home, right? Is that significant evidence?
No.
Why not?
Because she lives there. Her DNA is in there.
Of course, right? Right? Her DNA is going to be everywhere in that house, right? It's not a significant evidence, right? Okay, which means that the probability of having her DNA in there, the p-value, is very, very high. Okay, which means that it's not significant whatsoever. It's insignificant to find her DNA everywhere in the house, right? That doesn't tell me that she committed the crime, right? Okay, so we have to actually figure out another motive or another method to finding that she actually committed the crime. Get the idea? So far, so good? And this is exactly what we do with hypothesis testing. Okay? That is an overview. And that p-value is considered to be what we're looking for. Okay? The lower, smaller the p-value, and we're going to always compare that p-value to what we call the significance level, alpha level. If your significance level, your alpha, is your significance level, your alpha, if your p-value is smaller than your alpha, then it's highly significant, very significant. Okay? So therefore, if it's very significant, then usually, if you have very significant value, then you would reject null hypothesis and you accept your alternate hypothesis. Okay, so basic idea is that the suspect, okay, so in the courtroom, your null hypothesis is set to say what? What's your null hypothesis? What's your null hypothesis? What's your null hypothesis? Oh, where is this? Right here. Assume that null hypothesis is true, like the suspect is always what? Always what?
Innocent until proven
Innocent. So we have suspect equals innocence. Okay, and alternate hypothesis, what? Suspect guilty, right? Okay, so not innocent, we'll just say rather than guilty. Okay, we won't say not. You'll never hear, right? Guilty, right? Not innocent. Okay, so not equal to means not innocent. Okay, get the idea. So therefore, if you have a very significant data, right, then we know that the suspect is going to be not innocent, right? Which means that they're going to be guilty. Okay, so far so good. If you have a high p-value, right, most likely the person is going to be actually what? Innocent in this case. Okay, so if your p-value is greater than the significance level, then we have, so it says for p-value less than, then we reject null hypothesis. If it's greater than, we do not reject null hypothesis. Okay, do not reject null hypothesis. Okay, so far so good. And that's basically idea. Okay, I think you guys could go over through this one. What I want to do is focus on the next 20 minutes to go over a step-by-step process of hypothesis testing. Okay, now that you have an overview of what we're looking at, let's actually turn to, let's do this one right here. We did this right here. If you could actually ask for yesterday's, last night's, what is it? Open Zoom tutoring, right? Video link, then you could actually find how I did this right here, okay? But let's actually go on to example number, which one do you want to do? 2 or 3? Have you guys done 2 or 3? Okay, so let's do 2. Okay, because let's go in order. Okay, example number 2. So it says in 2000. Okay, so let me give you guys a minute to actually read this. So what parameter are we working with here? So in 2000, 58% of adult female lived alone. According to the US Census Bureau, a sociologist tests whether the percentage is different today by conducting a random sample of 500 adult females and finds that 285 are living alone. Okay, is there sufficient evidence at significance level, your alpha level at 10%, which is 0.10, right, to conclude that the proportion has changed since 2000? Okay, what parameter are we working with? What parameter are we working with?
Proportion.
Very good. Where does it say proportion here? Okay, percentage, right? When we're dealing with, and proportion here, right? So we have proportion. This is your parameter. Okay, so we know that we are dealing with proportion, okay, which means that we want to actually gather all the information. Okay, before we gather information, what is your observational unit? Who are we observing?
The females in the United States.
Right, so more specifically, we are actually observing, because we sampled 500
adult females.
Adult females, very good. Okay, what is the variable here?
Who lives alone?
Right, percent. So more specifically, percentage who lives alone, right? Okay, so far so good. Now let's collect the data, right? Okay, what is our X? What's the number of success? Which is basically, that's your variable, right? Okay, So out of 500 that we sample, right, how many actually lived alone?
285.
285, thank you. I think we should give Alexandria a little bit of MVP point here, right? She's very much, you know, right, participating, okay? N here, what's the sample size?
500.
Very good, okay. So far, so good, okay? Then we can actually figure out our p hat. What is our p hat? Our sample proportion. Okay, of course, 285 divided by what? 500. Okay, which gives us 0.57. Okay, we are collecting all the data here. Okay, so far so good. And which means that Q hat, do we need Q hat? No, not necessarily. Okay, we don't need Q hat. Okay, what is P? What's the population proportion? What's the population proportion? In 2000, 58%, right? That's the population proportion they give us to us, right? 58% of adult female lived alone, according to the US Census Bureau. And this is actually the whole population because they say Census Bureau, right? What is Q? Okay, for MVP point,
0.42.
0.42. All right, Michael wins some MVP points here. Okay, so far so good. All right, so now we're gonna actually, let me have you guys, if you guys could have a side-by-side screen, okay? I want you to open up when we're doing this. Oh, so I want you to, no, I'm sorry. So we're gonna go through these 4-step or actually 5-step process here. So number 1, state your null and alternate hypothesis. Number 2, right? Identify your significance level. Step number 3, calculate your test statistic. And step number 4, right? Using StatCrunch, we want to evaluate this, the p-value. Okay, so far so good. And that's what we're going to do over here. Okay, so step number 1. Number 1, right? Identify your null and alternate hypothesis. What is your null hypothesis for MVP point?
P equals 0.58.
Very good, 0.58. Okay, and your alternate hypothesis?
Q
What are we
equals-
claiming?
Oh,
What are we claiming?
0.57.
No, what are we claiming? We want a sociologist test whether the percentage is what?
Different.
Different, right? What do you mean by different?
It's not equal to.
so
Not equal to. Okay. Has it changed, right? Has it changed since 2003? So is there sufficient evidence, right, that the proportion has changed since 2003? Is there sufficient evidence that the proportion has changed since? That's what you're claiming. That's your alternate hypothesis. Okay? Is sufficient evidence that the proportion has changed since 2000. Okay? So we want to see, right? Because right now it's 2020, right? Has it changed? This is from 2000. Okay? So far, so good? Okay, so this is considered to be a two-tailed test, but we're not actually going to be focusing on that too much. Okay, step number 2. Step number 2, okay, identify your significance level if they don't give you the significance level, most of the time we have a default significance level at 5%. But if they give you the significance level, then we have alpha equals to 0.10. That's your significance level, okay? Identify your significance level, okay? A lot of the time, if we're dealing with two-tailed tests, we're gonna cut this by 2, and we have 0.5. You don't have to do this, okay? If you're actually doing this by hand, right, most likely then, and using a table, then we would actually refer to this significance level rather than this significance level, okay? But for now, you don't necessarily need to worry about this, okay? I just put that there, okay? So we wanna more focus on this one right here, okay? Focus on that significance level, okay? Step number 3. Step number 3 is to calculate your test statistic. Okay, test statistic by definition here is gonna be Z is equal to, or I think Professor Conley calls it test stat, which is equal to Z, which is P hat minus P all over square root of PQ over N. This right here, this bottom part, represents the SE, standard error. Okay, so far so good. Any question? Let's calculate that now. This is equal to, then what's our P hat? What's our P hat?
0.62.
0.57. 0.62. Where'd you get 0.62?
I was looking at a different problem that I did.
Minus P is 0.58 divided by square root of, okay, P 0.58 times 0.42 divided by 500, okay? I don't want you to put this into a calculator, okay? What I'm gonna do, I'm gonna actually switch this off, and then I'm gonna actually find the p-value as well as your test statistic at the same time, okay? So let's do that. So I'm gonna switch gear here. Okay, and then I'm gonna, you guys all have your StatCrunches open, yes? Okay. Okay, so what we wanna do is go to Stat, okay? Since we're dealing with proportion, right? Go to the proportion statistic, just like we done before with the confidence interval for proportion. We do exactly the same thing. Rather than confidence interval, we're just gonna go into hypothesis testing here. So we have one sample, and then we have summary of statistic, not the raw data, okay? So we have summary of data, and then push on that. Okay, number of success. What was the number of success here? What's X equal to? What was X equals to? 285. And what was the observation? How many number of sample
500.
500, very good. And our proportion was 0.58. And then we want not equal to. It's defaulted to not equal to, but you could change that to less than or greater than, right? As you could see, right? But we'll just leave it in that. Okay, so here, before we didn't click on this, we actually clicked on this, right? Confidence interval to figure out your proportion, right? 95% confidence interval for proportion, 90% and so forth, and we could change that. But all we need to do is just click over to the hypothesis testing, okay? Two things that I wanna actually mention is the p-value and the test statistics here. So when we click on this, and you don't even have to use your calculator this time, okay? The test statistic is this value right here, the z-stat, okay? That's your test statistic, okay? Of course, I also want you to kind of realize that's your standard error, okay? So I'm going to write that standard error. So this standard error is equal to 0.0221, and we get a test statistic that is equal to negative 0. Let's do this. We get negative 0.453. Okay, that's our Z, right? Test statistic. But more importantly, the most important thing here is this right here. P-value. Okay, and I'm going to actually state that P-value in bright pink. P-value. Okay, and then write that. So number 4, step number 4 is to calculate your P-value. Okay, P-value is equal to 0.6505. Okay, so far so good. Okay, any question there? Okay. I'm gonna stop sharing here. Let me start sharing from here. Okay, and that's what we get. Okay, so we get the test statistic, which is, I should actually do this in orange. Okay, if you had to do this by hand, okay, if you had to do this by hand, we will use, there's two approaches to this. You could do this by critical value approach or the p-value approach. Then if you're using a critical value approach, you will use that Z value. But since we're doing by StatCrunch, this is the most important thing right here. That would be the most important thing. Okay, your p-value. Okay, and he says right here, okay, this is your conclusion here, basically, right? And then the 5th step is to write your conclusion. If your p-value is what? Michael, state this right here. If your p-value is what?
Where is it?
Right here.
Oh, I can't see. Sorry, I didn't see it. Its p-value is greater than A. Which,
No, less than
A,
alpha.
Less than alpha, reject the null hypothesis.
And if you have a p-value that is what? Greater than alpha,
then do not reject.
You have to memorize this. Okay, always, it's always going to be the same. Okay, so now let's actually look at this p-value, and we're going to compare our p-value here. Let me actually just move this a little bit here. I'm going to compare this p-value to our significance level, alpha. Okay, so our significance level alpha, what's our significance level right there? Alpha is what?
0.1.
0.1. Significance level 0.10. Okay, is your p-value greater than or less than your significance level?
Greater
Than or less than? Greater than, right? If your p-value is greater than, let's go back here. If your p-value is greater than the significance level alpha, what do? What's your conclusion?
Do not reject.
Do not reject, null hypothesis. Here, do not reject. What do you mean by do not reject? What's another way of saying do not reject?
It's correct.
It's accepting, right? And rejecting alternate hypothesis. Okay, if we're actually rejecting alternate hypothesis, they're saying that there is not enough evidence to conclude that there is actually what? A change, right? Since 2000. So it has stayed exactly the same, right? Female who lives alone, the proportion of it hasn't really altered all that much, hasn't changed all that much, hasn't changed significantly enough to say, right, for us to say that it has actually increased or decreased or whatever otherwise, right? It has stayed around the same. So that's why we could reject the alternate hypothesis, right? Okay, and do not reject the null hypothesis here. So therefore, the conclusion, just like what we set up there, so 5, okay, at 10% significance level, the data does not provide, I'm going to put does not significant evidence to conclude that the proportion of adult female who lives alone has changed. Okay, so at 10% significance level, the data does not provide significant evidence to conclude. It does not provide significant evidence to conclude that the proportion of adult females who lives alone has actually changed. Okay, it's about the same. Okay, get the idea. This is basically a step-by-step process, right? You don't necessarily need to actually calculate any of this right here, I doubt, right? Because you're going to be using StatCrunch, right? I just showed you how to actually input it, right? This is the I say 5-step process of going through this right here, proportion. A p-value method of hypothesis testing regarding population proportion, okay? And with the z-value, with the mean, it's exactly the same thing, okay? It's pretty much the same. You collect all the information here. Number 1, state your null hypothesis. Number 2, state your significance level. Step 3, calculate your test statistic. Step 4, right? Using StatCrunch, figure out your p-value, and you compare to your significance level. If your p-value is less than the significance level, reject null hypothesis. If p-value is greater than the significance level, do not reject null hypothesis. So therefore, I should say over here, do not reject null hypothesis. Do not reject null hypothesis. Down, down, down. If you're not rejecting null hypothesis, you're of course accepting it, right? Okay, which means that if you're accepting null hypothesis, they're saying that proportion is equal to, right, 0.58. It hasn't actually changed. Okay, if you're accepting alternate hypothesis, it has changed. Okay, so those are your two different, right? One other thing before I let you guys go, I want you to read, okay? Please read this right here. There's 2 types of error, of course, we can make, okay? There is actually a 10% chance of when you incorrectly reject true null hypothesis, it's called a type 1 error. Alpha is actually the level of error, right? It's a type 1 error. It's a percentage of making a type 1 error. It's a 10% chance that we're making a type 1 error, which means, for example, right, we could actually, even though this person, right, say this is not a wife, this person who's a suspect, who does not have any relationship with them, right? Found was somehow had their DNA in the crime scene, right? But he really did not commit the crime. But he actually goes to the jail because his evidence, his DNA was found in the crime scene, and they found that, oh, he must be the one who actually committed the crime. But he really did not. So innocent person going to a jail. So far, so good. And that could happen. Okay, and there's many cases that has happened before. Of course, there are cases where, you know, really a guilty person, right, basically, right, got off scot-free. Okay, an actual guilty person who actually committed the crime got off scot-free, right, because there was not enough evidence to convict them, right? There's that chance. So there's two type of chance right here. I want you to read that type 1 error and type 2 error. Okay, so far so good? Any question? Hopefully this kind of clarifies what you're doing with the hypothesis testing, right? Okay, all right. So good luck with your exam tomorrow, right? Okay, of course, if you have any other question, Alex here and Michael is gonna be a big help, right? Throughout today, and all your trainers gonna be very, very, very helpful, okay, throughout. Okay, all right, rely on them. Okay, I'll see you guys. Tomorrow is the exam, right? Okay, so no class, right? No lecture or anything like that. So, okay, I'll see you guys then next week. Okay.